Okay, this is the Unit 2 test review for Secondary Math 3. If you look up here, I have written, remember that you can pause and rewind this video if you don't understand. So you might want to go back several times and look at a problem, what I did on it, until you understand it. Also, I suggest you go over each problem until you can do it by yourself 3 times. So I would do the problem. Watching the video, try it yourself first, then watch the video on that problem, and then see if you can do it 3 times on your own without looking at it. And if you can do that, that means you're ready for that problem. And then I would suggest also reviewing once more before you go take the test. But we're going to just start at problem number 1, and I am going to move through them fairly quickly because I want to make this video short, but remember, you can rewind and so forth. So on this one right here, number 1, it says factor each expression. So problems 1 through 4 are a review of what we did last unit, and so there will be 2 problems from last unit on this test. Now if you remember right, this is a special type of factoring. Notice that 9x squared is a perfect square. If you take the square root of it, you get 3x. And 1 right here is also a perfect square. The square root of that is 1. And remember, if this is a minus sign in between, which it is, we call it a difference of 2 squares. And it factors into 2 binomials. One of the binomials is the square root of 9x squared, 3x, and the square root of 1, 1. So 3x minus 1, and the other one is 3x plus 1. So that's called a difference of 2 squares. Problem number 2. This one also is a difference of 2 squares. The square root of 16x squared is 4x. So that's the first number in each binomial. The square root of 49 is 9. So that's the last number in each binomial. And it's a difference. So one of these is negative and one of these is positive. So 4x minus 9 times 4x plus 9. It's just like a trinomial where the middle term is 0. Like if you're looking for 2 numbers, I'm sorry, I did that wrong. The square root of 49 is 7. So if you look for 2 numbers that you times together and get negative 49, but add together and get 0, they would be negative 7 and positive 7, as well as 2 numbers you can times together and get 16x squared, which would be 4x. Okay, problem number 3 is a special type of factoring called a difference of 2 cubes. First of all, we are going to find the cube root of 8x cubed. The cube root of 8 is 2. And the cube root of x cubed is x. And then we're going to find the cube root of 27. The cube root of 27 is 3. Now we have a formula. So this right here is really 2x cubed minus 3 cubed. If we break 8x cubed down into its cube root and 27 down its cube root, we have a formula for factoring a difference of 2 cubes. It says that if you have a cubed minus b cubed, that's equal to a minus b times a squared plus a times b plus b squared. So we have figured out by taking the cube root of 8x cubed and getting 2x, and the cube root of 27 and getting 3, we found out what a and b are. A is 2x and b is 3. And so this one right here is going to factor, well, let's write it up here, a minus b, so it's going to be 2x minus 3. Because a is 2x, b is 3. And then you're going to take a and square it. So a is 2x, so you're going to go 2x times 2x is 4x squared. And then you're going to multiply a times b. That would be 2x times 3, which would be 6x. And then you're going to multiply, b by itself. It's b squared. So 3 times 3 is 9. And that problem is factored. It's as far as you need to go with it. Okay, this one is a sum of 2 cubes. It's the same formula, a cubed plus b cubed, except for that's a plus sign right there. So in the formula, we just have a couple of signs that change. So this is going to be a plus b times a squared minus ab plus b squared. That is the formula for a sum of two cubes. So once again, I take the cube root of 64, which is 4, and the cube root of x cubed, which is x. So that right there is a. And the cube root of 125 is 5. So that is b. So 4x is a and 5 is b. So I just plug them in to this formula. I have a plus b, so that's going to be 4x plus 5 inside parentheses. Multiplied by the quantity a squared, which would be 4x times 4x, which is 16x squared, minus 4x times 5, a times b, which is 20x, plus b squared. 5 times 5 is 25. And so that right there is my answer. Problem number 5. Problem number 5. The instructions for problem number 5 is simplify by factoring. So I need to factor that top trinomial to be two binomials. And since my denominator is x plus 7, I can kind of guess that one of my factors is probably going to be x plus 7. But we can check it out and see. I know that the first number in each binomial, this x, and this number that goes right in the first spot in that binomial, is going to be 7x squared. Well, if I times x by something and I get 7x squared, that has to be 7x. So x times 7x is 7x squared. I also know that the last number in each binomial, the number that goes right there and the number that goes right there, times together, give me the last number in the trinomial. So I just need to know 7 times what is 28? And the answer is 4. So we can check this out now. I can multiply this back together to see if it works. I know that x times 7x is 7x squared. I know that x times 4 is 4x. I'm going to write that over here because this is going to be part of my middle term. I know that 7 times 7x is 49x. And if I add those two together, 4 plus 49 is 53x. That is my middle term. And of course, I know that the last term, 7, and the last term, 4, and those two binomials times together gives me the 28. So I did factor that correctly. So I can cancel out the x plus 7's, because x plus 7 divided by x plus 7 is 1, and my answer is 7x plus 4. Okay, problem number 6 is just like that one. I'm going to factor that 5x squared minus 9x minus 2 into two binomials. I can probably guess, once again, that since my denominator is x minus 2, one of my binomials is also going to be x minus 2, so those cancel out. But we can check that out. First of all, I'm going to see x times what number that goes right here will give me 5x squared. So x times 5x would give me 5x squared, the first term. And I also need to know, for this last one right here, negative 2 times what would give me negative 2? Well, the answer is 1. Negative 2 times 1 is negative 2. And I could check that out and make sure it works, but I'll just multiply the two middle terms together and two outside terms together to see if they add up to the middle term, because I've multiplied the other ones. So x times 1 is x, and negative 2 times x is negative 10x. I add those together, that makes negative 9x, which is the middle term up there. That's the middle term, 9x. So I factored it correctly. I can see that x minus 2 divided by x minus 2 is 0. So my answer is 5x plus 1 over 1, if you wanted to think of it that way. And they cancel out, but 5x plus 1 divided by 1 is 5x plus 1. So that's my answer there. Problem number 7. The instructions for problem number 7 is to use synthetic division. So I make my little upside down division sign, and I need to take the number that I can put in for x and make the denominator 0. Well, if I put negative 2 in there, plus 2, that would make 0. It's just the opposite of that factor, x plus 2, so I'm going to use negative 2 for that divisor. And then my coefficients. I have 1 right here, even though we don't see a 1. My coefficient is 1. So when I list them, this number right here is going to be 1. Then I list the next coefficient for x squared is 13. The next coefficient for the x term is negative 12. And the last one is a constant negative 8. I will bring down 1. And that's how I set up the synthetic division. You always bring down the first number. Then I am going to carry out some multiplication. So I'm going to multiply this negative 2 times this 1 down here. Negative 2 times 1 is negative 2, and I'm going to put it under the next number, which is 13. And I'm going to add those two numbers. 13 plus a negative 2 makes 11. Then I'm going to multiply this negative 2 by that 11. I'm going to keep repeating that pattern. Negative 2 times 11 is negative 22. Then I'm going to add those two numbers. That makes negative 34. And then I'm going to multiply negative 2 times negative 34, and I'm going to get 68. And I'm going to add those two numbers together, and that's going to give me positive 60. So my answer, these are the coefficients down here, 1, 11, negative 34, and 60 is my remainder. So 1 is the coefficient for the term 1 less than whatever I divided into up there. Because I divided an x to the first into an x cubed, that reduces it to an x squared. So I have 1x squared, my coefficient's 1, and then we just go in descending order of exponents. Plus 11 for the x term, negative 34 for my constant, and then 60, which is my remainder, over my divisor, x plus 2. That is my answer. The next problem, number 8, is also a synthetic division problem. So again, I'm going to set this up. The opposite of negative 2 is positive 2, so they're right there. I'm going to put 2. My coefficients are 2, negative 3, 3, and negative 4. So 2, negative 3, 3, and negative 4. And bring down my first number 2, and I'm ready to begin. I'm going to multiply 2 times that 2, and I'm going to get 4. I'm going to add negative 3 and 4 to get 1. And I'm times 2 times 1. And I'm going to get 2. I add, I get 5. Times 2 times 5, I get 10. I add, I get 6. And so, since my first term up here is x cubed, and I divided an x first in that, that's going to reduce that to an x squared. And my coefficient for that number is 2, so 2x squared. And then in descending order of exponents, 1x plus my constant 5 plus my remainder 6 over my divisor, x minus 2. That is how you do synthetic division. Problem number 11. This time I'm asked to do long division. So in long division, set up my divisor out here. 4x plus 1, I'm dividing into 4x cubed plus 5x squared minus 3x plus 1. So I just begin by asking myself, what do I times this first term by to get this first term? Well, 4x times x squared will give me 4x cubed. So and then I'm going to distribute the x squared to my divisor, 4x plus 1. So x squared times 4x is 4x cubed, and x squared times 1 is x squared. I subtract at this point. I like to say change the signs and add. So I make that negative, make that negative. I add 4x cubed, I get 0. I add 5x squared and a negative x squared, I get 4x squared. I bring down the negative 3x, and I do repeat the process. What can I multiply 4x by to get 4x squared? And I know that is x. So I multiply the x by 4x plus 1, my divisor. So x times 4x is 4x squared. Those numbers should always be the same. X times 1 is x. Sorry. And I add those, I change the signs and add. That's the same thing as subtraction. That's 0. That's negative 4x. And you bring down the 1. And I repeat this process one more time. What do I times 4x by to get negative 4x? The answer is negative 1. So negative 1 times 4x is negative 4x. And negative 1 times 1 is negative 1. I change the signs and add. Once again, that's the same thing as subtraction. That adds up to 0. That gives me a remainder of 2. So my answer is the x squared plus x minus 1 plus my remainder 2 over the divisor for x plus 1. That is long division. Here's another long division problem. I will be dividing x squared plus 1 into x cubed minus 3x squared plus x minus 3. So what do I multiply x squared by to get x cubed? The answer is x. So I multiply x times the x squared plus 1. And so x times x squared is x cubed. And x times 1 is x. And I put it under its like term. You can pretend like under here is 0x squared. And I change the signs and add. X cubed minus x cubed is 0. Negative 3x squared minus 0x squared is 3x squared. And x plus a negative x is 0. And I bring down the negative 3. I put the 0x there just for spacing. And then I repeat the process. What can I times x squared by to get this negative 3x squared? And the answer is negative 3. Negative 3 times x squared is negative 3x squared. And negative 3 times 1 is negative 3. Put it under its like term. I change the signs and add. That adds up to 0, 0, and 0. So my remainder is 0. So my answer is just x minus 3. That's my answer right there. No remainder. Okay, problem number 11 is multiply and simplify. Probably the best thing to do right here is to factor each one of these expressions. I'm going to leave, 52 we could break down into 2 times 26, and 26 we can break down into 2 times 13. So 2 times 2 times 13, x squared y. 3x minus 27. That has a subtraction sign into it, so the best we can do is factor out a greatest common factor of 3. That leaves us with x minus 9. X squared minus 81 is a difference of two squares. We talked about those earlier. That factors will be x minus 9, x plus 9. And down here we have 13 times x cubed times y squared. Now earlier when I taught you this, we wrote the x like this x squared y on the top as x times y. We wrote the x cubed y squared on the bottom as x times x times x times y. And you can do that. But I'm going to cancel out common factors. Notice I have a 13 here and a 13 there. And that's all the real numbers that cancel out. I have an x minus 9 on the bottom and x minus 9 on the top that cancel out. X squared means x times x. There's two of them. And x cubed means x times x times x. So those two x's cancel out, and I'm just going to be left with x. And the y on the top is going to cancel with one of the y's on the bottom. That leaves me with 2 times 2 times 3 on the top, which is 12. In the denominator, I have an x and a y times an x plus 9. And that is my answer. Okay, this one's the same instructions. I notice that 6x minus 18 I can factor out a 6. That leaves me with x minus 3. And 2xy on the bottom. And I'm going to go back to that last problem, make sure it wasn't a division problem. No, it wasn't, so good. Okay. And then, on the top of this next one, we can break down 12 into 2 times 2 times 3. I'm going to break the x squared down to x times x, and then I have a y. And then in the bottom, x squared minus 9 factors to be x minus 3x plus 3. Once again, a difference, two squares. So now, I cancel out x minus 3's. Cancel out a 2. Cancel out an x. Cancel out a y. As long as there's one on top, one on the bottom, you can cancel it. So that's what I have left. I have 6 times 2 times 3, which is 36 on the top, times an x, over x plus 3. And that is my answer. Problem number 13. This one, the instructions are divide and simplify completely. So this is a division problem. Really, the only difference between a division and a multiplication is we take the reciprocal of the second fraction and we change this divide to a times. So I'm going to rewrite that with a times. And I'm going to do the reciprocal first, so I don't forget. The x minus 2 that's on top is factored already, and it goes on the bottom. And the 3x plus 3, we can take out a greatest common factor of 3. That leaves us with x plus 1. Remember, if I distributed that back through, 3 times x is 3x, and 3 times 1 is 3. Okay, over on the left side, I'm looking for two numbers I can multiply together and get negative 8. So when I add them together, I get positive 2. And I can say that 4 and negative 2 will work for that. Negative 2 times 4 is negative 8, and negative 2 plus 4 is a positive 2. Then on the bottom, I have a trinomial that factors into two binomials. I'm looking for two numbers times together and get 3. So when I add them together, I get 4. And I know that 3 times 1 is 3, and 3 plus 1 is 4. So that's the way that ends up factoring. Now I can cancel common factors. I have an x plus 1 here and 1 on the top. I have an x minus 2 on the bottom and an x minus 2 on the top. And that is all the factors. So on the top I have left with a 3 times an x plus 4. And on the bottom I'm left with x plus 3. That is simplified. Number 14 is also a division problem. So once again, I'm going to change it to a multiplication problem, and I am going to take the reciprocal of this last fraction. And so I am going to start with the bottom, which was the top, the x squared minus 9x plus 20. So I'm looking for two numbers times together and get 20, add together and get negative 9. And I know that both my numbers have to be negative because a negative times a negative is a positive, and a negative plus a negative is a negative. So I am saying they are negative 4 times a negative 5 is 20, and negative 4 plus negative 5 is 9. Then this bottom fraction up here goes to the top. Looking for two numbers times together and get 50, add together and get negative 15. Let's see, that would be 10 and 5, and they both have to be negative. Negative 5 times negative 10 is a positive 50, and negative 5 plus a negative 10 is a negative 15. Over on the left side, top binomial, or trinomial, we're looking for two numbers times together and get 24, add together and get negative 11. So I have 8 times 3 is 24, and 8 plus 3 is 11, so they have to be both negative. Negative 3 times negative 8 is a positive 24, and negative 3 plus negative 8 is negative 11. And on the bottom, looking for two numbers times together and get 80, add together and get negative 18. I know those are going to probably be 8 and 10, negative 8 and negative 10. Negative 8 times negative 10 is 80, negative 8 plus negative 10 is 18. I'm ready to cancel out factors that are the same on the top and bottom. I can see x minus 8, I can see x minus 10s, I can see x minus 5s. This is working out so nicely. All that I have left on the top is x minus 3, and on the bottom, x minus 4. And that is my answer. Problem number 15. My instructions are add or subtract and simplify completely. Well, in order to add two fractions together, I need a common denominator. If I break 16 down, it breaks down to 2 times 2 times 2 times 2, and then I have an x. And if I break 4 down, it breaks down to 2 times 2 times x times x. And I need to take every factor I see. All I see is 2's and x's, but I have to take it the most number of times it occurs in one of these fractions. And I can see that 2 occurs 4 times. So 2 times 2 times 2 times 2 is 16. And I can see x happens twice over here, even though it only happens once over here, so I have to take it twice. So x times x is x squared. So 16x squared is my common denominator. I could have also looked at the fractions up here and say, hey, 4 will go into 16 4 times, and this x times another x will give me x squared. So right here, I have my two fractions, and I'm going to write the common denominators in, 16x squared. And I know that my common denominator is 16x squared. I know this one right here on the left side was missing an x. If I times the bottom by x, I would have the common denominator, which means I have to times the top by x. Because x over x is 1. We call it a special one because when you multiply something by 1, it still stays the same value. However, in this case, the special one is going to change what it looks like a little bit. So I'd multiply x times 6, and I get 6x on the top. On the right side, so this first fraction, 6x over 16x squared, is equivalent to 6 over 16x. Okay, on the right side, I noticed that I was missing multiplying both the top and bottom by 4. And I know that 4 times 4x squared would give me the 16x squared. But I got to multiply the top by 4 as well. I need my special one, and I get 4. And then I just add the numerators, 6x plus 4 over 16x squared. Now, I'm not quite done with this one because I notice at the top I can take out a greatest common factor of 2. And on the bottom, I can rewrite that as 2 times 8 times x squared. And I notice the 2's cancel out. So my answer is 3x plus 2 all over 8x squared. Problem number 16, adding two rational expressions again. So, once again, I have 2 times x for my first denominator, and 2 times x for my second denominator. So, I notice that I have 2 x's in the first one, and only 1 x in the second one, but I have to take it both times. It happens twice in one. And I have 2 2's in the second one. I only have 1 in the first one, but I have to take it 2 times, and 2 times 2 is 4. So my common denominator is 4x squared. So I am going to write my two fractions over here. My common denominator, 4x squared. And I'm going to ask myself, what did I times this 2x squared by to get that 4x squared? And the answer was 2. So I got to times by my special 1, 2 over 2. And what did I times this 4x by to get 4x squared? And the answer is x. So I times by my special 1, x. So on the top, 2 times 5 is 10. And on the right side, 3 times x is 3x. And I have my common denominator, so I have 3x plus 10 on the top over 4x squared. There is no factoring the numerator up there, so nothing's going to cancel out, and that is my answer. Number 17, I'm subtracting these two rational expressions. First of all, I can see that this denominator over here factors bx minus 2x plus 2, once again a difference of 2 squares. And this denominator over here is just x plus 2. Well, my common denominator is going to be every factor I see in the denominator. I see an x minus 2, I see an x plus 2, and although this one has an x plus 2 and this one has an x plus 2, I only list it once, so since it's only once in each fraction. So that is my common denominator, x minus 2 times x plus 2. So I am going to rewrite this again, common denominators, before I do my subtraction. My common denominator is x minus 2, x plus 2. And so I just rewrote that one. This first fraction was not missing any part of the denominator, so it stays itself, so it's a 1 on top. Over here, I'm missing an x minus 2, so I have to times the top and bottom by my special 1, which is x minus 2 over x minus 2. So I got to distribute this x through. Now, this is also a negative x, so I'm going to change this to a plus sign, but I have to change that to a negative. I'm going to have to distribute a negative x. So negative x times x is negative x squared. Negative x times negative 2 is a positive 2x all over x minus 2, x plus 2. Now I notice that I can factor a negative x out of the top of that up there. So if I do that, negative x out of the numerator, I would get x minus 2. And on the bottom I have an x minus 2 times an x plus 2. And I notice that the x minus 2's cancel out. So my answer is negative x over x plus 2. Another subtraction problem. Right here, I got to factor this denominator so I can see. I'm looking for two numbers times together and get 3, add together and get 4. And that would be x plus 3 and x plus 1. 1 times 3 is 3 and 1 plus 3 is 4. And I look at my common denominator. Take every factor, x plus 3 and x plus 1. And even though it's x plus 3 again, I don't do it a second time because it's listed already in the first one. So this first fraction is going to stay the same. The second fraction, I multiplied My special one is x minus 1. Or x plus 1, sorry. That's what I was missing. And notice, once again, I have a minus sign right in the middle there. So I'm going to change it to a plus and make that negative. I'm going to distribute this, and that's going to be negative 5x minus 5. And so my numerators are x, well, I'm just going to do this all at once. I'm going to add these together. X plus negative 5x is negative 4x, and x, yeah, and then I have also a negative 5. Okay, over my common denominator, x plus 3, x plus 1. 4x, negative 4x minus 5. You know what? I just got thinking. I might have made a mistake on that last one. I don't think I added the first fraction to it. I'm going to go back and look at that one. Yeah, I did make a mistake. Let's go back and work this one. 1 minus a negative x squared. So once again, I'm going to change this to a plus. Oh, wait, I already did that. So that is a negative x squared on top and negative 2. So 1 minus x squared plus 2x. And now I'm confusing myself. Hopefully I didn't confuse you. To see if that factors. I am going to do this. I'm going to factor out, and I'm going to put the negative x squared up front, but I'm going to factor out a negative 1. And that x squared will become positive x squared. If I factor out a negative 1, that will become a negative 2x. And the 1 will become a negative 1 all over x minus 2, x plus 2. And nothing is going to, oh yeah, you know what? The top of this factors to be, no, it doesn't. There's not two numbers you can times together and get negative 1. Add together and get negative 2. So I could leave it like that, or you could have even left it like this as your answer. Hopefully I didn't make any more mistakes on that one. Ask me in class on Wednesday. All right. Okay, number 19 and 20 are solving equations. Remember, we're looking for the common denominator. Notice that x doesn't have a denominator, neither does 5. We can consider it 1. But my only denominator is x. So that's my least common denominator. I'm going to multiply both sides of this equation by x. And when I do it on this side, I got to times both terms by x. I got to distribute it. Those cancel out, and I get 6 equals x squared minus 5x. That is a quadratic equation. So I get everything on one side. I'm going to minus a 6 to both sides. I have x squared minus 5x minus 6. And that factors to be, I'm looking for two factors, two numbers I can times together and get negative 6, add together and get negative 5. That would be x minus 6, x plus 1. And so my solutions are 6 and negative 1. Remember, I need to check for extraneous solutions. Well, there's only one denominator here. It's x. If I put 6 or negative 1 in there, it's not going to make the denominator 0. So those are both viable solutions. Neither one of them make the denominator 0, so no extraneous solutions there. Number 20. You know what? I showed you guys the fast method of doing this. Whenever there's a single fraction on each side, you can just cross multiply. X times x plus 4 is equal to 4 times x plus 1. It's the same thing as if I multiply both sides by the least common denominator, which is x plus 1 times x plus 4. If I distribute, I get x squared plus 4x. If I distribute on the right side, I get 4x plus 4. I move everything to the left side. So I'm going to minus 4x, and my x's are gone. And I'm going to minus 4 from both sides. And so I'm going to get negative 4 equals 0. And that factors to be x minus 2, x plus 2. Once again, that's a difference of 2 squares. And so my solutions are 2 and negative 2. And neither one of those make the denominator 0. 2 plus 1 is 3. Negative 2 plus 1 is negative 1. 2 plus 4 is 6. And negative 2 plus 4 is 2. So those are both viable solutions, no extraneous solutions. All right. I've been sitting here talking to myself for 20 minutes. For a long time doing these 20 problems. So I probably made some other errors other than the one I caught. Hopefully not. And that's the end of this video. Remember, you can rewind it, look at what you need to again, especially on that one I messed up on. I think that was number 18. You can go over that one again and fix it.